in our schools, where the teaching of evolution has become a hugely sensitive issue for science teachers. This is multicultural Britain, and one of its fault lines runs straight through our children's classrooms. How do we reconcile scientific truth with the deeply held convictions that bind religious communities? Charles Darwin was the first person to grasp the extraordinary idea that life on Earth had evolved without the intervention of any god. And I've always been intrigued by how he himself wrestled with what that meant for religion. Darwin was deeply worried about how religion spread, not through reason and evidence, but by being seeded in children's minds at a young age at school. He wrote that it would become as difficult for them to throw off their belief in God as for a monkey to throw off its instinctive fear and hatred of a snake. Darwin became concerned by what he saw as the stupid classical education at Rugby School, dulling his eldest son William's once lively mind. So he was prepared to brave the snobbery of Victorian society to send his 4 other sons to the less prestigious Clapham Grammar School, because it had strong science education. 150 years later, Darwin would find reason to be equally anxious about what his children were being taught at school. The compromised values of multicultural Britain mean that teachers hesitate to offend the religious beliefs of their pupils, even when these directly contradict scientific fact. I worry they're tiptoeing too respectfully around traditional beliefs.
Some kids just won't accept it. That they're brought up in families where they just don't believe it, and that's an end to it. There's no lack of understanding of it necessarily. It's just we can't get into the business of knocking down kids' religions and the religions of families.
Why not, actually?
Why not? Because
because we teach science, and I would not feel comfortable talking about anything but science. So if I present the scientific case and I make sure they understand the scientific case, I think I've done my job.
Yeah.
But their acceptance of it is a separate issue.
For some students, truth isn't something they see coming through science, even though our emphasis is on ideas and evidence to support these ideas. A lot of students have a religious narrative that's very important to them. It's an important part of their life, through their family and their culture.
Would it be too unfair to suggest that these well-meaning teachers are running scared? Who could blame them? Obviously, what we believe is affected by our upbringing. But that doesn't mean we can't change our minds. We all have the right to see the evidence and re-evaluate our beliefs. These science teachers shouldn't be afraid to spell out the scientific truth derived from evidence.
I don't see that we can expect to convince them just by showing them the evidence.
Really? Why not?
Well, because they've got other evidence which they've been brought up with throughout their lives.
But that's not evidence.
No, to them it's evidence, though, isn't it?
Yeah. And to their parents.
We're talking about something very fundamental here. We're talking about young people. We're talking about identity. It's not our place to fly the banner of science and say there's no room for anything else. All we can do is present science. This is a way of thinking. This is science has given us so much. This is one way of interpreting life. We believe this is the way because we are scientists, but it's not my place to tell you that you're wrong.
We believe it because we're scientists. Do you really mean that? Or do you mean we believe it because the evidence is there in the rocks?
Well, that's what I'm saying. That's
yes,
because I'm a scientist and that's the way I view the world.
No, it's not because you're a scientist, is it? I mean, it's there. The evidence is there. Their evidence is not there. It's just made up. You don't believe that the Earth is round only if you're an astronaut. You don't believe Napoleon existed only if you're a historian. You believe these things because they're facts proved by evidence. Evolution is also a demonstrated fact. The truth really is out there. It's not a matter of opinion. Relativism, the quaint notion that there are many truths, all equally deserving of respect, even if they contradict each other, is rife today. It sounds like a respectful gesture towards multiculturalism. Actually, it's a pretentious cop-out. There really is something special about scientific evidence. Science works, planes fly, magic carpets and broomsticks don't. Gravity is not a version of the truth, it is the truth. Anybody who doubts it is invited to jump out of a 10th floor window. Evolution, too, is reality. You don't decide whether to believe it or not believe it on the basis of whim or culture. The evidence supports it. Evolution is the plain truth.
So for you, I mean, the theory of evolution is basically an explanation supported by evidence.
Yes.
In all your work, what is the single most overwhelming piece of evidence for you documenting evolution?
It's very hard to choose one because it's all so strong.
Like the detective. It's finding
That's right.
all the pieces together.
Like the detective. I suppose one thing I would say is that fossil evidence is not the most compelling evidence. Fossil evidence is very compelling, but it's not quite the most compelling evidence.
That fossil evidence isn't necessarily the most compelling, but certainly probably the most familiar to our viewers. Explain how fossil evidence works and why, again, the ordering of where fossils are found in different layers of the Earth's crust. Tell us something about evolution.
We are very, very lucky to have any fossils at all. It's a remarkably fortunate phenomenon, fossilization. But most animals that die never fossilize. Most species that die never fossilize either. So we have to look at it as a sort of rare, privileged trace of the evidence from the past. Now, there are, of course, gaps because, as I say, most species, most animals don't fossilize. So there are huge gaps in some places, small gaps in others. You cannot expect the fossils to provide you with a kind of cinematic replay.
Frame by frame of the entire story.
Most of the frames are missing. It's
Right.
like a film in which only 1 in 1,000 of the frames of the film are still there. However, what you can say is that not a single fossil has ever been found in the wrong place.
Now, this is a very important point you make,
Yes.
because not only does the fossil evidence kind of taken together point to evolution as a fact, but you say because of that is that evolution is calculatably falsifiable.
Yes.
That you could prove
Yes.
evolution did not take place if you found something in the wrong...
It would be so easy to disprove it if only you found something...
You found a rabbit in the Precambrian, for
Well, that
example.
was J.B.S. Haldane's famous example. And no such thing has ever been found.
On the monkey front, is that I think this also affronts some of our kind of modern conceit about being a human being. That, we can't be evolved from monkeys. I mean, you make the point that our evolution is a little bit more diffuse than that direct line. Tell us a little bit about our family tree, our evolutionary family tree.
If you go back some 25 million years to see what our ancestor would have looked like then, it would have looked pretty much like a monkey. So we're not descended from modern monkeys. Modern monkeys and we are descended from older animals, which were much more like modern monkeys than they're like us, and so it would probably have been reasonable to call them monkeys. We are not descended from chimpanzees. Chimpanzees are descended from the same common ancestor as we are, which lived about 6 million years ago. It would have looked more like a chimpanzee than like a human, but you wouldn't call that a chimpanzee by any means. It certainly wasn't a chimpanzee. So I think it's a matter of how you use language. There are some times when you say, well, the ancestor of fish and ourselves would surely have been called a fish. It would have looked like a fish and tasted like a fish. So it's reasonable to say we are descended from fish. But once again, we are not descended from modern fish. Modern fish and we are descended from ancient fish who are no more.
Richard Dawkins, I want to thank you very much for joining me. It's been a real pleasure.
Thank you very much.
Well, at the moment, I'm certainly looking again at the whole question of a recent African origin for modern humans, because that's been the leading idea of the last 20 years, that we had a recent African origin, that we came out of Africa and we replaced all these other humans that were outside of Africa. And we're having to reevaluate that now, because genetic data show that the modern humans who came out of Africa maybe 60,000 years ago actually interbred with Neanderthals, first of all, and then some of them later on interbred with another group of people called the Denisovans over in Eastern Asia. So we are not purely a recent African origin. We're mostly recent African origin, but there was contact with these other so-called species. So we're having to come and look at out of Africa again, and also even look at the species concepts we've got, because if these species are interbreeding with each other, are they really distinct species? So we've got to look again at the species question. We're having to reevaluate the out of Africa theory, and we're going to have to reevaluate our species concepts, because on one view of thinking, species are self-contained units, they don't interbreed with other species. And for me, the whole idea of Neanderthals as a different species is really a recognition of their separate evolutionary history. The fact that we can show that they evolved through time in a particular direction, distinct from modern humans. So certainly, you know, I'm thinking a lot about species concepts. I'm thinking about the out of Africa model, and also looking back into Africa itself, because I think that the idea that modern humans originated in Africa, I think, is still a sound concept, both behaviourally and physically. We originated in Africa. But I've come around to thinking that it wasn't a simple origin. 20 years ago, I would have argued that the origin was maybe in one place, maybe in East Africa or in South Africa. There was a period of time just in one place where modern humans became modern. Perhaps forced by climate change, modern humans physically changed and changed behaviourally under a lot of stress to become modern humans, a punctuational event. Now I think it's not simple in that way. I think that we can see the kind of focus, the centre of evolution of modern humans in Africa, moving around from one place to another, driven by climate changes. So at times we see innovations and behavioural change and physical changes in North Africa, at other times we see them in East Africa, and other times we see them in South Africa. And there are parts of Africa where we have no record at all, and we have to bear that in mind too. Africa's a huge place. We've got no ancient fossils at all from Central Africa or West Africa, none at all. So I think we have to bear in mind that our picture is also limited in terms of the sites that we've got and the information we've got. So for me, the African origin is still an uncertain process. We don't know exactly when it happened. We don't know exactly where it happened. And I think it will be more complicated. Recent evidence suggests that when modern humans appeared, and we have modern human fossils from Ethiopia at 160,000 years and at Herto, and 195,000 years from Homo kibish. So these do look physically like a more robust version of people today. But I think we're also seeing that the archaic ancestors of those people didn't just disappear when they evolved into modern humans. They actually continued, in some parts of Africa, probably living alongside, in a sense, their descendants. And so the Broken Hill specimen, one of the most famous examples of Homo heidelbergensis, I'm spending time now trying to complete the dating of that material, which was found way back in 1921. So it's only now that we've got the techniques to actually find out how old that specimen is, and I think we may have surprises that it'll be younger than many of us think. And not only that, there seem to be archaic humans in Tanzania and Kenya that are lingering on after modern humans have appeared. And even a specimen that I published on just in the last few weeks with colleagues from Nigeria. It's the oldest fossil from Nigeria, from a site called Iwo Eleru. It's about 13,000 years old. And yet if you look at it, you would say that it's much more ancient. You'd say that it was more than 100,000 years old. So this reminds us that we have a very biased picture of African evolution, and it reminds us that there could be more primitive relics of human evolution hanging on not only outside of Africa, in the form of maybe the Neanderthals and the Denisovans and over in Flores, this strange thing, the Hobbit, but in Africa itself, archaic humans could have been hanging on in parts of Africa as well, and on some new genetic analyses, they're putting in DNA into modern humans as recently as 35,000 years ago. So even in Africa, the process is more complicated than we thought. In terms of modern humans, this clearly does mean that in a sense, some modern humans have got more archaic genes than others. That seems to be so. So it does lead us on to kind of ask again this question of, what is a modern human? And I think that some of the most fascinating research that's going to come up in the next year or two will be homing in on the DNA that we've acquired from Neanderthals. Some people have acquired from Denisovans. Some African people have acquired maybe from Homo heidelbergensis. And yes, this fossil from Nigeria at 13,000 years old does show what you can call mixed modern human and archaic features. So I think this is giving us a clue that we do need to look again at these fossils, and the species boundary is broken down in a sense in places, and we can look at the DNA now and actually try and see what's producing some of these differences between modern human populations. Are they due purely to differentiation from an African ancestor, or are they due to the input of some of these archaic genes? Obviously, the new way of looking at out of Africa does mean we have to revisit the whole question of regionality, races, if you want to call that, of modern humans. And I think there's no doubt that the fundamental processes that produced modern humans were, first of all, we had the evolution of the shared features of modern humans in Africa. So there we're talking about the high rounded skull, the small brow ridge, the chin on the lower jaw, the lightly built skeleton. Those features pretty certainly evolved in Africa. But then later on, superimposed on them were the regional so-called racial features. So in that sense, those features are add-ons to the shared modern morphology. And there's not a lot of DNA involved in most of those features, we know that. So for example, eye colour is just one tiny bit of DNA. So it doesn't need a lot of DNA to produce the regional differentiation we see today. So I think it's true to say that those genes are small in the big picture. We share far more DNA and genes across the world than the ones that indicate differences between populations. Darwin was puzzled, of course, by the evolution of many of these features, and if we read The Descent of Man, his favoured view for the evolution of many of these regional racial features was that they were sexually selected, or we could say culturally selected. And I think, he was probably right about some of those things, that we can see that skin colour clearly has a relationship with ultraviolet light, with getting a balance between having enough UV getting into your skin to produce vitamin D, but not too much of it that it will damage the skin cells and produce skin cancers, or will destroy folic acid, which of course will then affect pregnant women. So there's a balancing act in skin colour, and I think there's no doubt natural selection's at work there. But when we look at other features such as, say, oriental eyes, or the shape of the kind of hair we've got, maybe Darwin was right that sexual selection is at work there. And as populations spread out in small numbers, cultural preferences for attractiveness might have driven some of these differences. And again, not much DNA involved, but producing quite striking differences between these populations.